All right, today we're doing something a little different. We're not just going to look at a finished AI product. Nope. We're going to walk through the builder's journey. You'll see step by step how you can actually build a complex AI app that is totally compliant and audit ready right from the get-go. So let's dive in. So that's the big question, right? How in the world do you build a sophisticated AI that's audit-proof from the very first line of code? Well, the key isn't about slapping on some features at the end. It's about a total shift in your thinking. And that brings us to the core philosophy behind this whole project. See, most people would build a tool first and then try to bolt on compliance later on. And let me tell you, that's a recipe for disaster. This project flips that whole idea on its head. The goal here is to build what they call a compliance instrument. Think about it like this. Every single function, every little piece of code is there for one reason: to serve a regulatory purpose. It's a total reversal of how things are normally done, and it's designed specifically to avoid those black box decisions that drive regulators crazy. Okay, section 1, teaching the AI the rules. So where do you even start with something like this? Well, you don't jump into writing code or designing fancy interfaces. Nope. You start by setting strict, non-negotiable boundaries for your AI. You gotta teach it the rules of the game before you even let it play. So here we are inside the Google Antigravity platform. The very first thing you do is give the mission a name. In this case, AI H Unit Mapper Audit Ready. Pretty clear, right? Then you pick your stack, which is Python. And this is super important because it gives you all the essential data management tools you're going to need, like Pandas and Streamlit, to do the heavy lifting. Now this is where the real magic happens. Before you even let the AI agents do anything, you feed them these 3 critical files. These are your digital guardrails. One defines the workflow, another sets up the data schema, and the third, and this is the most important one, lays down the non-negotiable audit rules from the regulator, TEQSA. These files basically act as the system's conscience. It can't break the rules because the rules are baked in from the very beginning. All right, section 2, architecting with AI agents. So now that we've established the rules of engagement, it's time to actually design the blueprint. And you're not doing this alone. You're assembling a team of specialized AI agents, and each one has a very specific job to do. And this diagram, it just illustrates the architecture perfectly. Look at how everything, and I mean everything, operates inside that dotted line. That's the TEQSA regulatory boundary. You've got 3 distinct agents: the planner, the coder, and the auditor. This separation of duties is absolutely key. It means you can plan, build, and test all at the same time, without one of them messing up the other. So let's break down who does what. The planner, that's your architect. It designs the whole system blueprint. Then you have the coder. That's your builder, the one writing the actual Python code. And finally, the auditor or the reviewer. Think of this one as the tester. Its entire job is to try and break the system, to throw worst-case scenarios at it and make sure every single risk gets flagged correctly. Okay, so how do you even kick this whole thing off? You just talk to it. You give the planner agent its mission in simple, plain English. I mean, look at this prompt. It's not complicated code. It's just a clear instruction telling the AI what to build. And it's very specific, demanding things like a dual-pane interface and, most importantly, an evidence-based audit engine. And based on that simple prompt, the planner gets to work designing the AI audit engine. Now, this is not just some simple keyword match. Oh no, it runs 3 super critical checks. First, semantic similarity. So it understands the meaning behind the words, not just the words themselves. Then it does a gap analysis to see what's missing. And this is the big one. It checks for assessment equivalence. So it makes sure that, say, a final exam in one course is really, truly comparable to a final project in another. That's a huge deal. All right, section 3, building the audit engine. So we've got the rules, we've got the architecture, now it's time to actually build this thing. And this is where we really see the crucial role of the human expert in refining and perfecting the application. And this slide, wow, this just perfectly illustrates that human-in-the-loop process. On the left, you see the AI's first try, just a generic, totally unhelpful match. Yes, that gets rejected fast. A human expert jumps in and provides feedback right on the interface, demanding a detailed table. And the result? On the right, you get a compliant, evidence-rich output that's actually useful for an audit. That's the partnership right there. So, what's happening behind the scenes? Well, the coder agent isn't just off writing whatever code it wants. No way. It's given very strict constraints. It has to use specific libraries to process PDFs, and its functions can never just return a simple true or false. It's forced to return a structured dictionary. basically a detailed log of evidence. This is what prevents any of those black box decisions. Okay, so you think the coder did its job right, but how do you know? You try to break it. On purpose. Here, a human gives a direct command to the reviewer agent, saying, hey, run a test case for a bad match. Make sure the gap flags get raised. This isn't just about checking if it works, it's about proving that it fails in exactly the right way. And boom, the system works exactly as designed. The test comes back with a big red status high-risk flag. But it doesn't just say no match, it tells you exactly why, listing the missing assessments, the missing learning outcomes. This successful failure is the ultimate proof that the system is reliable and that it's sticking to those audit rules. Let's move to Section 4, creating the defensible paper trail. So you have to remember, the whole point of all this work, the rules, the agents, the testing, it all leads to one thing: creating a verifiable, undeniable, audit-proof record of every single decision that the system and its human operator make. So at the end of the day, the application produces 3 key compliance artifacts. First, you've got a finalize and sign button that locks the record down with a human assessor's name and a timestamp. Can't argue with that. Second, there's a save to CSV function for the master audit log. And finally, you get the official compliant letter of offer for the student. This whole thing is the defensible paper trail. Now, after all that incredibly detailed compliance engineering, you'd probably think deploying this thing is a total nightmare. But it's not. The whole application gets packaged up, and with just 2 standard commands in your terminal, it's up and running right on your local machine. All the complexity is in the logic, not the launch. So what's the ultimate takeaway here? Success isn't just about how fast or how automated the system is. The single most important metric is defensible decision-making. The system only truly succeeds when it can provide the hard, concrete evidence needed to fly through a formal audit with no questions asked. That's the real win. You know, when you build compliance into the very DNA of an AI system like this, it offers a powerful blueprint for trust and accountability. It really makes you wonder, if you can do this for higher education, what about other high-stakes industries? Think about finance, healthcare, or even law. This whole compliance-first design approach, it could be the key to finally unlocking AI's potential in pretty much any regulated field.